Welcome back with a new lesson 13.1 Trigonometric Ratios. Our lesson objective is to write the trigonometric ratios for the sine, cosine, and tangent of an angle using the basic terms of a right triangle. If you remember, we studied before the right triangle and we named the sides of this triangle as A, B, and C. The corresponding angles for these sides, we will call them capital A, capital B, and capital C. And also, we will remind you by the Pythagorean theorem which we took before, which was saying that a square plus b square is equal to c square, because maybe we will need it to solve some problems on this lesson later. Side A and side B are called the right angle sides, but side C, we call it the hypotenuse. Our work in this lesson and the coming lessons are going to be only on the right triangles. As we learned before, that the ratio is the comparison of two quantities by division. If we make a ratio between the sides of this triangle, we will have something called the trigonometric ratios, and we gave names for these ratios. If you find the ratio between side A and C, this we call it sine of angle A. And the ratio between side B and side C, this we will call it cosine angle A. But the ratio between side A and side B, it will be called tangent of angle A. So these three ratios now belongs to the angle A. The sine of angle A is equal to the opposite side of angle A divided by the hypotenuse. And cosine of angle A is equal to the adjacent side to angle A divided by the hypotenuse. And tangent of angle A is equal to the opposite side divided by the adjacent side. So side A is the opposite side to angle A, and side B is the adjacent side. But if we were talking about the angle B, side B will be the opposite side for angle B, and angle A will be the adjacent side. So if we want to find sine of angle B, this is going to be equal to the opposite side, which is B, over the hypotenuse. And if we want to find cosine ratio for angle B, this is going to be equal to the adjacent side of angle B over the hypotenuse. And if you want to find the tangent of angle B, you will divide the opposite side length over the adjacent side length. You need to memorize these ratios. So always remember that the sine ratio of an angle, for example B, is going to be equal to the opposite over the hypotenuse. Cosine ratio for any angle on a right triangle is equal to the adjacent side divided by the hypotenuse, and the tangent of any angle in a right triangle is going to be equal to the opposite side to this angle over the adjacent. These three ratios are so important for us in this lesson. Let us take now some examples on this. Suppose that we have a right triangle as the one shown to you, and you have the length of the hypotenuse is 75 meters, and the length of the side A is equal to 45 meters, and we want to find sine angle P, cosine angle P, tangent of angle P. To find sine P, you need to divide the length of the opposite side to angle P by the hypotenuse. To find cosine, we need to divide the adjacent side to angle B by the hypotenuse. And to find the tangent, we need to divide the opposite side of angle B over the adjacent. And maybe you noticed that the question didn't give us the length of side B, and here we need to use the Pythagorean theorem to find it. So let us do that first. A square plus B square equals to C square. So 45 squared plus B squared equals to 75 squared. From this, we can have that B squared is equal to 75 squared minus 45 squared, and this is going to be equal to 3600. And from this, we can say that B is equal to 60. Since we have A, B, and C now, we can continue finding the trigonometric ratios for angle B. So sine angle B is going to be equal to 60 divided by 75, and this is equal to 8/10. The cosine of angle B is going to be equal to adjacent, which is 45, divided by the hypotenuse, which is 75, and this is going to be equal to 6/10. Notice here that sine and cosine are less than 1, and this is always for all angles. Any angle, sine or cosine, the largest value can be for them is 1, and the smallest value is -1. So most of the values for sine and cosine are between 1 and -1. It will not be greater than 1 or less than -1. Also, to find the tangent, we will divide the opposite side, which is 60, over the adjacent side, which is 45, and this is going to be equal to 1.3 repeated. Notice here that the tangent can be equal more than 1. Now, the same example. Suppose that we want to find the three trigonometric ratios for angle A, not angle B. We will do the same work, but with respect to angle A. So, sine ratio for angle A is going to be equal to the opposite to angle A over the hypotenuse. Cosine angle A is going to be equal to the adjacent to angle A over the hypotenuse, and the tangent of angle A is going to be equal to the opposite to angle A over the adjacent of to angle A. So here the opposite to angle A is equal to 45 over the hypotenuse, which is 75, and this is going to be equal to 6/10. The cosine ratio for angle A is going to be equal to adjacent to angle A, which is equal to 60 over 75, and this is going to be equal to 8/10. And the tangent for angle A is going to be equal to the opposite over the adjacent, which is 45 over 60, which is gonna be equal to 45 over 60, and this is equal to 75/100th. So as a quick summary for what we said now, if you want to find any of the trigonometric ratios for a right triangle, when it is given to you the lengths of its sides, you just use these ratios to find it directly. If there is a missing side in this triangle, you can use the Pythagorean theorem to find it first and then use these ratios. Also, you have another way to find these trigonometric ratios if you are given the measurement of the angle inside the right triangle. So, for example, suppose that angle A here is equal to 30 degrees. Then you can find sine A by using your calculator. So you just press the button sine and insert 30 after it, and you will be given by your calculator the answer, which is equal to half. Also, you can find cosine for your angle here using the calculator, which will give you the answer as square root of 3 over 2. Also, using your calculator, you can find the tangent for the angle 30 by pressing the tan button and inserting 30 degrees, and this will result 0.5774 approximated to 10,000th. Now suppose that angle B is equal to 70.3 degrees. Let us find the three trigonometric ratios for this angle. So sine angle B, which is 70.3, using the calculator, you just press the sine button and insert 70.3, and this will result 9,415 10,000th approximated to 10,000th. The same way, let us find cosine for the same angle. Use your calculator to find it, and the result is 3,371 approximated to 10,000th. Also, the tangent for the same angle results 2 and 7,929 approximated to 10,000th. Sometimes you will be given that cosine angle B is equal to 4,602 10,000th, and he's asking what is the measurement of angle B. To find that, also you can use the calculator, but in an opposite way. So you can press shift button and then you can press the cosine button, which you can find over it written cosine to power -1, which we mean by it the inverse of cosine. and then you can insert the angle cosine given to you in the question, and the calculator will give you the measurement of angle B, which is equal to 62.6 rounded to nearest 10th degrees. Suppose that you are given that tangent B is equal to 2 and 316,000. Find angle B. So using the calculator, again, you can press shift, then you can press the tangent button, which has the function inverse tangent over it, and then insert the number given to you in the question. This will give you the measurement of angle B, which is 66 degrees and 6/10 approximated to nearest 10th. By this, we reach the end of our lesson. Thank you.